Dear students, today we are going to start a new lesson in grade 9 mathematics part 3, 22nd lesson sets. Objectives. By studying this lesson, you will be able to identify the finite and infinite sets, write the subsets of a given set, identify equivalent sets, equal sets, disjoint sets and universal sets, identify the complement of a set, and represent sets using Venn diagrams. Introduction. First of all, let me remind some previously learned things regarding sets. You have learned earlier that a set is a collection of items that can be clearly identified. The items in a set are called elements or members. These elements can be numbers, people, letters of the alphabet, other sets, and so on. And also remember, there are some sets which do not have elements. These types of set are known as the null sets. Null set is denoted by curly brackets and it has no elements inside it. And also it represents using this symbol too. This symbol. A circle and a line which cut across. And also, if we think about an example of null set, we can take even numbers between 0 and 1. Think about this example. Even numbers between 0 and 1. Can we find even numbers, any even numbers between 0 and 1? No, we can't. It means it has no elements. That set has no elements. Let us recall what was learned previously about the different ways in which a set can be expressed. This is the first way. Describing the set using a common characteristic by which the elements can be clearly identified. Look at the example. Set A is odd numbers between 0 and 10. And the second way is writing the elements within curly brackets. Same example has taken for the second one also. There elements of the set A have been written. What are the elements? 1, 3, 5, 7, 9. The third and the last way is using a Venn diagram. I think this is the most appropriate and perfect way of representing data, according to my point of view. So, third way is using a Venn diagram. 22.1 Finite sets, infinite sets, equivalent sets and equal sets. Take the first one. Finite sets. What are finite sets? Finite sets are sets which have a specific number of elements. Look at this example. Set A consists of multiples of 5 between 0 and 25. Here you have to write the multiples of 5 in between 0 and 25 only. So what are the multiples of 5 in between 0 and 25? 5, 10, 15, 20. Only 4 elements are there. It means it has a finite number of elements. Then the second one, infinite sets. Infinite sets are sets which have an infinite number of elements. It doesn't have a limit. Take the example, multiples of 5. You know several multiples of 5. So you can write several elements under this example. 5, 10, 15, 20, 25, so on. So the third one, equal sets are sets which have the same elements. Equal sets. Look at this example. A. A is even numbers between 0 and 10. B is digits of number 28,464. What are the elements of set A? 2, 4, 8, 6. What are the elements of set B? 2, 4, 6, 8. Can you see the elements of both sets are same here? So we can say these A and B are equal sets. Then the fourth one, equivalent sets. Equivalent sets are sets which have the same number of elements. Please don't mingle these equivalent sets with equal sets. Equivalent sets have the same number of elements only. Look at this example. X is odd numbers between 0 and 10. Y is vowels in the alphabet. Vowels in the English alphabet. So what are the elements of X? 1, 3, 5, 7, 9. And Y? A, E, I, O, U. Number of elements of X is 5 and also number of elements of Y is 5. The number of elements are same, but the elements are not same, but the number of elements are same. 22.2 Universal set and subsets. Universal set is a set which containing all objects or elements and of which all other sets are subsets. Subset is a set of which all the elements are contained in another set. At the end of this presentation, you will find out some links which are related to this universal set and subsets. You can refer them for further learning. Let's see how do we apply the things we have done so far in sums. In your textbook, turn to page number 13 and also page number 16. Exercise 22.1. I have taken Roman number 1 and Roman number 3 from first question. Roman number 1 is set A. It is multiples of 5 from 0 to 50. Here you have to find out whether it's a finite set or an infinite set. What can you say about this set A? Multiples of 5 from 0 to 50. So they have given a limit. What is the limit? 0 to 50. So what are the elements of this set? 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. So it has a particular number of elements. So this is a finite set. Then look at the second one. Set C is numbers that can be written using only the digits 0 and 1. What can you say about this one? How many numbers can you write by using 0 and 1? Is there a limit for this? No, you can write hundreds, thousands, 10,000s, 100,000 numbers by using 0 and 1. It does not have a limit. So these type of sets are infinite sets. So this one also an infinite sets. And also I have done the first question of exercise 22.2 here. You can refer this thing also. Venn diagrams. The universal set is represented by a Venn diagram by a rectangle as shown below. It means usually we draw rectangles to represent universal set in Venn diagram. The subsets of a universal set are represented using round or oval-shaped figures. Subsets are represented by circles or ellipses. Let's see how to draw a Venn diagram and how to include the information given under certain questions. Look at this example. Universal set includes numbers of 1, 2, 3, 4, 5, 6, 7, 8. And there's another set A which includes 2, 4, 6. So, can you see in both two sets, are there any common elements? Yes, 2, 4, 6 are in universal set also. So, we can say this A is a subset of this universal set. How do we draw a Venn diagram from this? Firstly, as I said, you have to draw a rectangle to represent universal set and put the universal mark. Then, you can draw a circle and name it as A. After drawing the Venn diagram, you can enter the elements. When you enter the element, you can start entering elements on subset. It means firstly you can enter these 2, 4 and 6 on this circle. It means this red color area. On this red color area, you can enter 2, 4, 6. After that, once you enter 2, 4, 6, what are the remaining numbers? Once you enter 2, 4, 6, what are the remaining numbers there? 1 is remaining, 3 is remaining, 5 is remaining, 7 and 8 are remaining. So, you can enter these numbers on this area of this rectangle of this Venn diagram. This green color area. On this green color area, you can enter these remaining numbers. What are these numbers? 1, 3, 5, 7 and 8. So can you see there's a proper picture of a Venn diagram after including all the details properly. 22.4 Intersection of sets. In this case, when two or more sets are considered, the set consisting of the elements which are common to all the sets is known as their intersection. As an example, can you see there are two sets. Set A includes the elements of red, yellow, pink, blue, purple and green. Set B consists of yellow, green and purple. So, the set consisting of the elements common to both A and B is yellow, green and purple. Therefore, the intersection of the sets A and B is A intersected B equals yellow, green, purple. 22.4 Disjoint sets and union of sets. Let's assume if A and B are two sets shown below. Set A includes the elements of 2, 5, 8. Set B includes the elements of 3, 4, 6. Can you see, are there any common elements here? No, there are no any common elements here. So, how do we draw these two sets in a Venn diagram? Firstly, you have to draw the rectangle in order to represent the universal set and put the symbol of universal set. After that, as these both A and B do not have common elements, you can draw them separately or inside of the universal set. It means A separately, B separately. Once you draw A, you can include the things of elements of A. After drawing B, you can include the elements of B. This is the way of representing a disjoint set in a Venn diagram. So, what is the union of sets? When two or more sets are considered, the set which consists of all the elements in these sets is known as the union of sets. Union of sets is like a combination of two or more sets which are given to consider. I have taken the same example. Set A includes 2, 5, 8. Set B includes 3, 4, 6. The union of the sets A and B is 2, 3, 4, 5, 6, 8. 22.5. Complement of a set. Let me explain this one also with examples. Can you see there are three sets? First one is the universal set. It includes the elements from number 1 to 10. And the second set is set A, which includes 2, 5, 6 and 9. Can you see there's another set which is known as A dash. It includes 1, 3, 4, 7, 8 and 10. A dash is the set of elements which belong to universal set but not to A. Therefore, the whole region in the Venn diagram which does not belong to A belongs to A dash. Let us represent this information in a Venn diagram. Firstly, you have to draw the rectangle to represent the universal set and put the symbol of the universal set. After that, draw a circle as a subset and name it as A and include the elements of set A 2, 5, 6, 9 inside of this circle. After that, you can include the elements of A dash inside of the rectangle but outside of the circle. Let's recall the things we have done so far. Set with a finite number of elements are called finite sets. Sets with an infinite number of elements are called infinite sets. Sets with the same elements are called equal sets. Sets with the same number of elements are called equivalent sets. A set which contains all the elements under consideration is called universal set. Okay children, now we have reached to the end of the lesson. Here I have included some links to you to refer. This will be helpful for your further learning too. So I just invite you to refer these links and watch these videos and get more information about sets. And also now you can attend in your exercises in your textbook part 3 from page number 10 to page number 27. Thank you for listening. Have a nice day.